Welcome to the Good Energy House. This is Tim Eian, the owner of TE Studio Architecture, and I'm also the owner of the house. This is Minneapolis's first certified passive house new home, and we built it in partnership with Tanner Construction and a number of gracious and wonderful other project team partners. Good Energy Haus replaces a dilapidated old home in northeast Minneapolis. Good Energy Haus is a two-story building. It features about 2,200 square feet. The main floor is an all-open living, kitchen, dining area with an additional guest bedroom / office and an accessible powder bath, as well as a mudroom that also hosts the mechanical system for the home. The living space is generously fenestrated. We have a vertical space in there with a little balcony up on the second floor, and the daylight in Minneapolis is wonderful, particularly in the winter months, and it can really penetrate that space deeply from the south and also from the west and illuminate the space basically all day long without artificial lighting. The second floor features 3 bedrooms and 2 bathrooms, one in a dedicated master suite, as well as our laundry space. Good Energy Haus is built in one of the more interesting climate zones on the planet with extreme winter and summer conditions. The foundation is entirely wrapped in EPS foam, and we spent a great deal of detailing and time on air sealing the building really well. While the foundation is built with insulated concrete forms, the exterior walls are essentially double stud wood framed walls that are cellulose filled, and the roof is a simple truss roof system that is also dense packed with cellulose insulation. The windows are German-made triple pane insulated frame units. They're installed into the structural frame of the building and over-insulated on the outside. I'll open this up here. So we have exterior motorized shades. I pointed that out on a couple of occasions here to control the heat that comes through the windows, also give us privacy, control glare. This is app controlled. We're working with Loxone. And Hella manufactures the shades themselves. Loxone is our control partner, and what we can do here in the app is we can drill down to a room and decide we're going to send this into shading mode, and now you can see the shade starting to move, and what it's going to do here is it's going to come down all the way and then right back up so that the individual slats go into a position that is based on today's sun angles to perfectly shade this room while maximizing daylight. And that's one of the great things of working with a strong controls partner, in this case Loxone. They have all this built into their product. This thing is smart enough to shade individual windows based on sun and indoor temperature in our home. It could do that individually for each facade as well. So in the morning on the east, midday on the south, and then in the evening on the west side. And you can see it shows the perfect shading position. At any moment in time, we can override this to our heart's content. We can send the unit all the way up or send it all the way down into privacy or night mode. I'm gonna close it right now so you can see what that is like. And just for completeness sake, I thought I'd give you the numbers here as well. The airtightness strategy worked really well in this house. We achieved a 0.22 ACH 50, and in general, we met all the passive house criteria for the home. Currently, there's no PV system installed on the roof for a Passive House Plus certification, as we are completely powered by wind power. So the energy that the house does need is provided by a Mitsubishi Cold Climate air-to-air heat pump. These units are very well suited for our extreme climate zone. There's one outdoor unit that connects to an indoor vertical air handler. We also have one mini split head in the garage, which is super insulated and air sealed as well. There's an additional dehumidifier as shown here, as well as a smart thermostat to control the entire heating, cooling, and dehumidification system. Hot water is produced by an electric tanked heat pump hot water heater. It is also connected to a wastewater heat recovery unit that pre-warms the city water that comes into the unit. So on the second floor, on the north side, we decided to make an upstairs laundry space. So we have a washer and a dryer side by side. It's a high efficiency washer with a heat pump dryer, which is really the best choice currently for a passive house. So this unit, extremely energy efficient and little waste heat, and obviously the main selling point, there's no exhaust. So the effluent from the machine goes into the same drain as the effluent from the washer. So next to washer and dryer, we have our Zender Q Series ERV. These are the lungs of the building. This is the heat recovery ventilator. It's a very basic setup in this house. We were able to bring the air from the outside right into the machine through the wall. So we have perhaps the world's shortest air intake at, I think, a couple of inches before the elbow. This here in the front is the exhaust. So this is the stale air from the house being brought back to the outside. And then to the right here, we have the manifolds. The one in the front is the return from the house. Behind it are the supplies. There's a total of 20 home run pipes. The supplies go to bedrooms and living spaces. The returns, basically kitchen, bathrooms. And the machine is the latest from Zender. It's a very efficient heat recovery core, energy recovery I should say. It's an ERV version with over 90% recovery potential in the core, and a very great interface that's app-based, and it's just a pleasure to commission and run and operate. Alright, with the induction cooktop and the oven down below, we also decided to install a recirculating range hood. These things are great. They don't have an exhaust, which doesn't work in a passive house. We do exhaust with our ventilation system, which happens to have an inlet right above me. So this is what transports the air to the outside with heat recovery in the winter and heat recovery, or cool recovery I should say, and moisture rejection in the summer. And just some final thoughts. The Good Energy Haus is a carbon neutral site. We also used extensively sustainable and renewable materials and local resources to make this building, as we always do in our practice. goal is to blend economy and efficiency as well as sustainability and create something that is beautiful and that people will enjoy well into the future and care for. Well, thanks for joining the tour today, and goodbye.